Well, pre-calculus classes, good morning, good afternoon, or good evening. One thing I am going to mention here as we do move from 4.1, we do cover some of 4.3 before 4.2, and then we will come back and finish day 3 of 4.3 after that. So do be aware that, yes, we do go a little bit out of order here. So I think that in 4.3, you'll definitely see some things that you probably remember from a couple of years ago in geometry as we go back and look at some right triangle trigonometry. So I know one of the other things that we'll often tell you is, with math, we usually aren't going to penalize you for spelling. Well, one of the times where your spelling does matter is if you remember that mnemonic. I'm guessing every geometry teacher that you had 2 years ago likely reminded you or showed you SOHCAHTOA. And basically what that refers to is that if you have the angle, the non-right angle, in a right triangle, the sine of that angle is the measure of the opposite leg over the hypotenuse. The cosine of theta is the length of the adjacent leg over the hypotenuse. And then tangent is the ratio of the opposite leg over the adjacent leg. So that's, again, where SOHCAHTOA comes from. So again, sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent is opposite over adjacent. And again, just to even clarify, when we say opposite and adjacent, those are referring to the legs in relation to theta. And then obviously the hypotenuse is the long side. Now, if you had Advanced Studies Algebra 2, you may have seen these, although I also know that with the way this last year when you may not have seen these. But there are 3 additional trig functions that are all reciprocals of one of these. Cosecant, which is what that one is the reciprocal of sine. Secant, which again, since these may or may not be new, I do want to actually write out what those are, is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So we have the 3 that you've all seen. We have the 3 reciprocal ones that you may or may not have seen. So an example here, find the 5 trig functions of theta if tangent theta is 7 over 3. Well, again, when you have the 7 over 3, that's opposite and adjacent. So in relation to theta, opposite leg is 7, adjacent leg is 3. First thing that I'm going to recommend is finding the hypotenuse. To do that, we'll use Pythagorean theorem. So for the hypotenuse, it is, and actually, I'll even just say the hypotenuse squared, is 7 squared plus 3 squared, so that's 49 and 9, which is 58. So the hypotenuse, as we square root it, is square root 58. All right, so find the other 5 trig functions. Well, we might as well start with the easy one. If tangent is 7 over 3, well, cotangent is 3 over 7. That's how the reciprocal identities work. From there, now, sine of theta. Well, the sine of theta is the opposite leg over the hypotenuse, which 7 over radical 58. Well, now we will need to go ahead and rationalize. We don't want to leave the radical in the denominator, so that's 7 radical 58 over square root of 58 times square root of 58 is just 58. From here, sine was 7 over radical 58. I always go ahead and write this down even if you know what it's going to end up here. And the reason is if I want the reciprocal, use 7 over radical 58. Don't use this. Otherwise, you create a lot more work for yourself. So cosecant is radical 58 over 7. Then the final two are cosine, which adjacent leg over hypotenuse is 3 over radical 58, which again, as we rationalize, 3 radical 58 over 58. And then, because I am kind of running out of room here, as we get the reciprocal of cosine secant, radical 58 over 3. So, again, sine, cosine, certainly tangent, things you've worked with before. Whether or not you've seen cosecant, secant, or cotangent, those are how those three work. All right, find the angle in degrees and radians. Well, what we're now going to do is you can, honestly pick one of these. I'd probably actually use the tangent of theta is 7/3. Well, you can't divide a tangent. The way you actually find theta to get rid of the tangent is you use the inverse. So what I'm going to do is take tangent inverse. So those cancel. And then the tangent inverse of 7/3 is 66.8 degrees. Now, radians. Again, to convert, so there is one answer. To get the conversion, we just multiply by pi over 180. For this one, because that's already rounded, I am going to go ahead and just use the decimal. .166 radians. And because we did get that decimal approximation, go ahead and include radians in your answer. So there are some things that you've probably seen before. Some additional things that I think you've likely seen before are the 30, 60, 90 triangles and 45, 45, 90 right triangles. Those were the special right triangles. And in terms of memorizing these, eventually we're going to kind of show you how these fit in with the unit circle. So I would say you don't necessarily have to, know, all of these, because we'll kind of talk about some ways you can determine them. But when you have a 30, 60, 90 triangle, the relation of the sides are 1 radical 3 for the long leg, 2 for the hypotenuse. If you plug into the Pythagorean theorem, 1 squared plus radical 3 squared will equal 2 squared. For the 45, 45, 90, since the angles are equal, so are the two legs. And then 1 squared plus 1 squared will equal 2. And then when you square root it, radical 2. So if we now go ahead and set up all of our, relationships using SOHCAHTOA here, well, the sine of 30, opposite over hypotenuse, is a half. The cosine of 30, adjacent over hypotenuse, radical 3 over 2. The sine of 60, opposite over hypotenuse. One thing that we'll certainly talk about, these are the same. And then I know I'm kind of going out of order here. The cosine of 60, adjacent over hypotenuse, matches the sine of 30. Now, tangents. Well, opposite over adjacent for 30 is 1 over radical 3, which as you rationalize is radical 3 over 3. And then the tangent of 60 is just radical 3 over 1, or radical 3. All right, so those are the 6 exact values from the 30, 60, 90 triangle. For sine and cosine of 45, well, one thing that's nice, the opposite or the adjacent are the same. So sine and cosine of 45 will both be 1 over radical 2, which again, as we rationalize that, radical 2 over 2. And then I'll just directly put that one there. And then of all 9 of these, easiest one by far, well, opposite over adjacent is 1. All right, so I don't know if your teacher in geometry ever mentioned this to you, but you know, there's a sine, there is a cosine. There is a secant and a cosecant. There is a tangent and a cotangent. Well, in all of those, the co stands for the complement function. So if theta is an acute angle, now one of the other things to just know, these are all interchangeable, 90 or pi over 2. I could have said the sine of pi over 2 minus theta, tangent of pi over 2 minus theta, cotangent of 90 minus theta. So just know that, you know, 3 of them we use degrees, 3 of them we use radians, but those are interchangeable. Well, the sine of 90 minus theta is cosine theta. What that means, the sine of 30 and the cosine of 60, well, the angles are complements. The value of sine and cosine at 30 and 60 is the same. Just like right here, cosine 30, sine of 60. These are also the same. So the sine of 90 minus theta is cosine. The cosine of pi over 2 minus theta is sine. Tangent, 90 minus theta is the cotangent of theta. And then cotangent of pi over 2 minus theta is tangent. Sine and cosine are complement functions. Tangent and cotangent are complement functions. Secant and cosecant are also complement functions. So those are some identities that we'll use, and these are things that you should know. You know, I will tell you, you will need to know your reciprocal identities, your complement identities. Again, we'll eventually show you a real easy way that you'll be able to memorize all of those. And then just a few other things here to finish up the first part of 4.3. So find a cofunction with the same value as the given expression. And this should actually say the secant of 50 degrees. Well, here's how these work. Basically, all you do is you find the complement of the given angle. So the secant of theta will equal the cosecant of either 90 or pi over 2 minus theta. Now, do you have to actually write out this work? Absolutely not. I'm just letting you see where that came from. So secant of, or cosecant, excuse me, 40 degrees. If you have one in radians, you'll just use pi over 2. So here, cosine is the sine of pi over 2 minus theta. Which is pi over 8. I should have actually written that in, not theta. Now, as far as what we are going to need to do here, get a common denominator. So it's the sine of 4 pi over 8 minus pi over 8, which is the sine of 3 pi over 8. All right, find theta in degrees and radians. Well, from here, sine of theta equals 0.0145. Well, it's just like over here. If you're getting rid of either a sine, a cosine, or a tangent, you will use the inverse function. And when I do that, the sine inverse of 0.0145 is 0.83 degrees. And then, as it also says, find it in radians. So multiply by pi over 180. And this is just a very random happenstance that you also get 0.0145 radians. That's actually a very crazy random occurrence. You'll see this next one, they won't be anything at all alike. So, cosine of theta equals 0.4565. Well, to start, take the inverse. And when we do that, 62.84 degrees. You know, obviously, as you work through things on Pearson, they'll tell you what they want you to round things off to. And then to convert that to radians, pi over 180. .097 radians. So as I was saying, you can see that that very odd happenstance on the first example usually won't occur. So, all right, one last example, solving for x. There's a couple of different ways you could do this. If you remember your exact values from the other page, certainly you can do that. Or, here's where again we can use SOHCAHTOA. You know, it just kind of depends on how you want to go about this. If you're using SOHCAHTOA, pick one of the angles. I don't know if I want to use the 30-degree angle. In relation to the 30-degree angle, we have the opposite and the adjacent, so I'm going to use sine. So the sine of 30 degrees equals 12 over x, and then from here, if I solve a problem like this, I like to make this, you know, sine of 30 over 1 and cross multiply. So 12 equals x times the sine of 30, and then divide. And when you do that, you get 24, which, as I was saying, if you remember your special right triangles patterns, great. Short leg, hypotenuse, it's going to be half of the hypotenuse, which is what we found. But that finishes up our first part of section 4.3.